Hello, BCSD third graders. It's Mrs. Whitman again, back with another math task explanation. Today we're looking at equations and deciding if those equations are true or false. A lot of times my students get tripped up with this because they look at the equation and they see things like the letter E and they say, well, Mrs. Whitman, why are there two numbers after the equal sign? Well, sometimes when we get equations, you're going to have more than one number after the equal sign because there is no rule that says you always just have to have one number or a specific answer, product, or sum after the equal sign. Sometimes you will have more than one number, and what you're really being asked to do is you're being asked to decide whether or not both sides of the equal sign are balanced or equal, okay? I will show you what I mean by doing E for you. So when I look at E, I see, and I'm going to use different colors for different sides of the equal sign. This is one side of the equal sign, okay? And here's the other side of the equal sign. I have to see if both sides of the equal sign are the same or not. If they are the same, it is perfectly acceptable to write it this way, and the equation is true, okay? So let's just do the math on both sides and find out. Okay, for E, I see that 3 times 4 is in parentheses. So I have to do that part first. 3 times 4 is 12, okay? And I'm going to bring down that times 2. Now 2 times 12 is 24. Now let's see if the pink side of my equal sign ends up being 24. 8 times 3, I know, whoops, get my pink here. 8 times 3, I already know from my math fact experience that 8 times 3 is indeed 24. So it ends up that both sides of the equal sign are the same. That means that this equation is true. It is balanced, and it totally works to write it that way. Okay. Let's just take a look at B real quick so you can see an example of one that wouldn't be true. Okay, in B, I already know that 7 times 5 is not 34. It is 35. 34, whoops, give myself a little bit more room here. 34 does not equal 35. If you ever see an equal sign with a slash through it, that's what it means. It means they are not equal. They are not balanced. Okay, so this one is false. Okay, I'm going to do one more for you. I think I'll do this other one. I'll do G, because that one looks like it's the most intimidating. You'll find out that it's really not. But in G, we have parentheses again, so we always have to do those parentheses first. So I'm going to, again, use two different colors for two different sides of the equal sign. My pink side and my orange side. So in my parentheses, I have to do 10 plus 2 first. That's 12, okay? Now I still have that times 4, and when I do that, that is 48. Okay. And by the way, you can do whatever math strategy that you need to do to figure out 4 times 12 if you don't have it in your head like I do. All right, let's see if that equals, balances the other side of the equation. 40 plus 2 is 42. So does 42 equal 48? It certainly does not. The two sides do not match. Therefore, this is also false. Okay, I'm going to let you do the rest of those on that page. But one thing I wanted to point out was this page for day 14. They're starting to get you to think about something we call unknowns in math. And unknowns are very, very, very important. let's just read this little blurb right here. This is pretty important. Sometimes in order to solve a problem, you need to do more than one step or use more than one operation. Here's an example. Okay, so it sounds like we're going to be doing like something like this. We see 5 times 6, so that would be multiplication, and then plus 7, that's addition. So that's what they're talking about. When you have more than one type of math in an equation, this part that says more than one step or use more than one operation, that word, that's what they're talking about there. Okay, now let's look at the directions. Write an equation with a letter for the unknown. Well, in this example, they used t as the unknown. The unknown sometimes is written as a letter. Sometimes it's written as a question mark. Okay, in this case, it was a letter. Sometimes it's written as a question mark. And sometimes it's just written as a box. All of those are the same thing. You're probably more used to seeing the unknown represented as a box or a question mark at this point in your education. But we need you to start to get used to seeing it as a letter, because as you move on and go further into your math career, unknowns are always represented with letters, okay? And I know it may seem kind of weird to think of letters in math because you're so used to working with numbers, but all you need to know is that it just means that there's one part of the equation that you need to solve, and there's one thing we don't know. In the example, that thing that we don't know is the total. 5 times 6 plus 7 equals the total. And we don't know what that total is. So they're calling the total t. Okay, let's see how that applies down below in number 1, where we have to write an equation with a letter for the unknown, then solve. Number 1, Whitney went to the hobby store. She bought 3 model airplanes for $4 each. She received $8 in change. How much money did she start with? Okay, let's go back and look at the math language being used here. She bought 3 model airplanes for $4 each. Okay, that sounds like multiplication because she's buying 3 of something and they all cost the same amount. Okay, so $4 each. She received $8 in change. How much money did she start with? Okay, so to figure out how much money she started with, we have to figure out how much money she spent on these model airplanes. So that would be 3 times $4 would be the first part of it. Okay, so she would be spending $12 on the model airplanes. Okay, I'm just going to leave that 12 down there for you to think about. And then she receives $8 in change. Okay, how much money did she start with? If she receives $8 in change, then that means if we take $8 and add it to what she spent, that would give us the amount that she started off with. So again, 3 times $4 is the amount that she spent on these airplanes, plus the $8 that she received in change would give us the money that she started with. And I can use any letter to represent this because this is the part that we don't know. This is the part that we have to solve. Since we're talking about money, why don't we just call it M? So M is our unknown in this case because we don't know how much money that she started off with, but we can solve it because we just wrote an expression for this. And now we're going to solve that expression. So I've done part of the work already. 3 times $4 is $12. Now if I add $12 plus the $8 that she got back in change, the original amount of money that she must have had is $20. So M equals $20. Alrighty, I think that about does it for today. I'm going to let you go ahead and do the rest of that on your own, and I will see you tomorrow with day 15.